Okay, now let's look at some more interesting things we can do in the where clause by using Boolean logic to combine multiple predicates. You'd think it'd be straightforward to use Booleans like ands, ors, and nots in the where clause, and it is, but there's some interesting and somewhat subtle connections between putting Boolean logic in the where clause and using traditional set operations between queries like intersect and union of two queries. So let's see some examples to illustrate how this works. First, we're going to look at SIDs of sailors who've either reserved a red or a green boat. All right, we're going to do this with our Boolean logic in the where clause. So we're taking from the boats and reserves table the cross product of those two tables, but we're restricting it in the where clause to matches on BID. So we're looking for reservations for particular boats identified by BID. So that's got to be true, and the boat color has to be red or the boat color has to be green. And for those matches, we're going to output the SID, the sailor ID of the reservation. So those are reservations of sailors who've reserved a red or a green boat. All right, let's look at a different way of writing that query. Same query up there versus a different way of expressing the query. In this first query block, right here, we're looking at taking that cross product of boats reserves, restricting it to BID equals BID, and looking for red boats. So that's the SID of sailors who've reserved a red boat. And then we're taking the union, which is to say including the tuples from that query and tuples from another query, where we're doing the same thing, but we're getting tuples where b.color equals green. So we're taking all of the reservations for red boats, outputting the SID, and we're unioning it with all of the reservations for green boats and returning the SID. And this union all says, let's not remove any duplicated SIDs if we see them. So we'll get each SID out if it's for a red boat or a green boat. Okay? Those two queries are equivalent. They're going to give you the same answer. Now, let's make a subtle change. Let's look at the SIDs of sailors who reserved a red and a green boat. So I want a sailor who's reserved both colors of boat. So let's look at this first query. What are we going to do? We're going to find pairs of boats and reservations that match on the BID, and the boat color is red and the boat color is green. Think about that for a minute. Versus this query, which is going to take the red boat reservations, just like we did before, and we're going to intersect that set of SIDs with the green boat reservations. All right, you should get a sense that these are different. Now think about why for a minute. The second query is going to have a tuple in the output if that sailor ID appears in the red boats and that sailor ID appears in the reservations for the green boats, right? So if you've reserved a red boat and you've reserved a green boat, you'll appear in both of these queries, and therefore you'll appear in the intersection. What about up here? Here what we're saying is I want to find reservations for a boat where that boat's color is both red and green, which is a very different thing. Now we're looking for a boat that has two different colors in the color field. That's not possible in the relational model. You can't have a tuple with two values in the same field. The boat color is either red or green or something else, but it's not red and green. So this first query is going to return nothing because there's no such thing as a boat that has two values in the color field. All right, so it's not always obvious how to convert from the Boolean logic in the where clause to a set-oriented representation like intersect. So here the intersect representation of the query is much more natural than here where this query actually doesn't make sense. By contrast, with the or and the union, we were able to get the same query written two different ways. So be careful when you write your where clauses.